Good afternoon, YouTube. So I got my step-down converter hooked in here. It has an inline fuse, but I also put a fuse in my fuse block just to make it easier to connect and disconnect. It's easier to pull the fuse out there than it is to get to the one in the wire. You can see the red light there is on, so this has been running now for several days, and yeah, it works just fine. So that's basically my standby current there, about 1/3 of an amp. Now I do have a few things on the 12 volt side. I've got like a voltmeter and a dual USB charging port running. So those things are on all the time. I also have my doorbell hooked up, but that shouldn't use any current. And I think that's all I have connected right now. So that 0.34 amps, that also includes about the meter and the freezer standby current. So I've tried turning on all the lights in the garage, and the thing works just fine. It puts out about 12.4 volts at no load, and then when you completely load it up, it drops down to maybe 12.3. So actually, one thing I need to do is, before I had some DC step-down converters on some of my LED lights out here, because during the day, when the charge controller was charging my 12-volt system, it would get up to like 14 volts. Some of my LEDs didn't like running that high. I started burning out LEDs in some of the lights I had. So I put some step-down converters to keep it down close to 12 volts. Well, now this thing keeps it at 12 volts, so I think I can get rid of those step-down converters. Need to make up a couple labels to put onto my cover there on the fuse block there. Get those labeled. I don't think this one here has a cover for it. That's my old 12-volt fuse block. And then I've got to straighten up the wires a little bit. I had to kind of pull them out to get them to fit. So I probably need to disconnect those and rerun some of the wires to make them a little cleaner. This will be the first time I will be able to see how much power the garage uses versus how much the house uses DC power-wise. It's quite cool in here now, mid-50s, so don't have any problem with overheating. I'll have to see what it looks like in the summer when it gets up in the 80s up here, because the attic roof up here gets kind of toasty in the summer. One of the reasons I left a little bit of room on this board in case I need to add like a cooling fan or something like that. Before I only had 20 amps at 12 volts. I had 240 watts of power available. Now I've got 600 watts on the 12 volt side, plus a bunch more on the 24 volt side. I was kind of running into a limit before, like it was when I added my media PC on the house system. I think when it's running it uses maybe 40 watts, but when it first boots up, it probably uses over 60 watts, maybe 5 or 6 amps, and that startup surge would be enough to shut the 12 volt system down. The PC didn't like that. You had to reboot it, and I did it 1 week with the freezer only, and that used 330 watt hours per day, or 1/3 of a kilowatt hour per day. I got the 12 volt step down converter running on New Year's Eve, and we were at about 4,800 watt hours. So now we've put on about 1,500 watt hours in 3 days. So yeah, running about a half a kilowatt hour a day out here, mainly the freezer and then running some of the lights and whatnot. So during the winter, I don't use the 12 volt DC lights a lot. I'm going to drain the battery and it's going to be cloudy. Why drain the battery? I'll just run the 120 volt lighting circuit. But in the summer, I use the 12 volt LEDs almost all the time because it's basically free power coming in during the day. So yeah, without doing a lot of lights, it's about a half a kilowatt hour a day out here. But yeah, anyway, I thought I'd show you the DC panel in operation. We're running 12 volts, 24 volts. So yeah, if you have any questions about that, post up in the comments section below. And as always, thanks for watching.